We have an exercise, following exercise, and we want to use superposition method to calculate the currents. We have two sources, so you have to divide this circuit into two. We take first E2, and then later we take E1, and we calculate the current as follows. I will show you the two circuits. So we have to take the first source and calculate the currents, and the second source to calculate the other currents. So let's start with the first circuit. This is a short circuit. We replace it by the resistance of the generator, but here the generator is ideal, so the resistance is 0. So here we have the resistances are equal, so it means that this point and this point have the same potential. So it means that this current will be 0. There is no connection, so it means the first thing we can write that E5 prime is equal to 0 because voltage here are equal. So it means that this point and this point have the same potential. What can we calculate? We can calculate now the current I6 prime, which is have two resistances in parallel in series with two resistances in parallel. R over 2, resistance is 20, so it means that we have E1 over R over 2 in series with R over 2. So it means we have the result is 12 over 20, and this is 0.6 amps. Okay, we can calculate now E1 prime is negative because it's flowing in this negative side to this one, so it's half of the current will flow here, half of the current, so it means we have minus 0.6 and here 0.3 amps. E3 prime is equal to half of this current, so it means 0.3 amps. E2 prime will be equal to E1 prime. Is it equal to 0.3 amps, and E4 prime will be equal to minus, I think, because we have chosen the side, that's right, minus 0.3 amps. And what is, we calculated all the currents, and we go to the other circuit. So we can write down the first values. E1 prime is equal to minus 0.3 amp. E2 prime is equal to 0.3 amp. E3 prime 0.3 amp. E4 prime is equal to minus 0.3 amp. E5 prime is equal to 0. E6 prime is equal to 0.6 amps. Okay, let's now go to the other circuit. I think the other circuit is, we take E2 on. So here it's same thing. We have this point has the same potential because this is a voltage divider. The voltage at this point and this point are equal, so it means that this connection doesn't exist, so it means the current is 0. So now we can calculate I1 second, because they have two resistances in series. There is E2 over 2R, so it's 24 over 40 is equal 0.6 amp. Is that right? Okay. E2 second is the same thing, is E2 over 2R, 24 over 40, 0.6 amp. Okay, if I3 second is equal to I1 second, and it's equal to 0.36 for second. Here it has the same sign as I4, so it means it's 0.6 amp. E5 second will be the sum of these two currents, so it means 0.6 plus 0.6, 1.2 amps. I6, we said it's equal to 0. So let's write the values here now. Here I1 second got 0.6, I2 second 0.6 amps, here I3 second is equal to 0.6 amp, I4 second equal to 0.6 amp, I5 second it's equal to 1.2 amps, and I6 second it's equal to 0. So I1 is equal to sum of the two, it's 0.3, I2 is equal to 0.9, sum of the two, I3 is equal to 0.9 amp, I4 is equal to 0.3 amp, I5 is equal to 1.2 amps, I6 is equal to 0.6 amp, and that's it. Let's check the results. If I haven't made a mistake, 0.3, 0.9, 0.3, 1.2 and 0.6. And thank you very much.